This is the latest project here at the airport. It's a single seat, ultralight category. Should weigh in, at the 250 pound or so level. Of course, it's electric powered, which is kind of strange for me. I don't usually do much with electricity, but we thought we'd try this out. See if we could do something different. And it's typical Bearhawk construction. Chromoly steel tubing, framing, and the framing layout is very similar to some of the other Bearhawks. And it's got an aluminum wing, although the wing's not completely covered with aluminum. It's got a carbon fiber leading edge, which is formed to fit the leading edge like the aluminum would, which is riveted and bonded on, which is part of the structure of the wing. And there, Mike's bringing me over a little sample of our tail feathers. This horizontal stabilizer, that's all aluminum with bonded construction, and we use a little weldment on the ends where tubes are connected together. We need some extra strength, and
a lot of lightning on it too.
Yeah, it doesn't weigh much. It's about 1 pound for a tail feather like that. Yeah, it's set up a lot like a Bearhawk. It's got flying cables in the back instead of solid rod. We're using cable, but it's a little bit lighter. Nickel press sleeves and so forth. Could use wire ends that were swedged on. If you wanted to, they might be a little nicer, but the nickel press works well. It's got landing gear is similar geometry, but instead of using a coil spring, which is kind of heavy, we're using a urethane die spring, which is much lighter than the steel spring. Spring characteristics are good, and the dampening characteristics are fairly good on urethane. It doesn't bounce back like a bungee cord or something. We hooked the motor up according to some information that I got with the motor, and another fellow that's helping me put it together, and we got it all wired up basically, but the controller doesn't seem to be sending the power to the motor, and we're fighting with that, trying to decide whether it needs to be programmed or something. At this point we're kind of a little bit baffled by it, but I guess with some help from other people we'll probably get it going. At one time this controller and motor and the batteries, which I bought all from the same place, did work. At least I was told they did, but we haven't got it going yet. That's the batteries, which right now are in this little wagon, are just plugged into the airplane. We run the wagon over by the back of the right side of the airplane there and plug it in to do our test runs. I didn't want to mount the batteries in the airplane yet because I'm not even absolutely sure we're going to use these batteries, although they do have enough capacity for probably 45 minutes of flying time or something. But there's other batteries coming out all the time. We might end up if something comes out fairly soon, we might try something else. We're going to have to mount some battery up in front of the firewall, and we'll have to mount some of the battery in the back behind the pilot, but there's room to do it. I have to weld some mountings in there for it, but it shouldn't be bad to do. I haven't covered it yet because of that. We need to sandblast the fuselage and paint it, and then we can cover it, but I really like to get the batteries, decided what we're doing with the batteries and which ones we're using, and if that motor and controller is going to be the final thing for test flying, or if we're going to end up with something all different. So I'm holding back on covering it until after I'm sure I'm all through welding things, particularly welding supports for the battery boxes.
What do you figure it weighs as it sits?
Well, right there, I think with the landing gear and everything on it, and the motor and all that, I think it's probably about 120, right around 120 pounds. And the batteries, they weigh about 70 pounds if we use those batteries. The wings weigh about 25 pounds apiece. We got the wings made. They're up in the shop, hanging on the ceiling. One of them is. The other one's down in my basement getting ready to put the leading edge on it. They weigh about 25 pounds apiece. I'm pretty sure it's, you know, if you don't count the batteries, it's going to easily come in under the 250. And we'll have to decide just to handle the batteries, whether it's, there is, as far as I know, there's no real spec on it at the time, whether it's gasoline or baggage or what you call the batteries, but because they are removable like baggage is. You can add batteries or subtract batteries like you can add gas or subtract gas. That's still to be determined, but I think it's going to come in okay on weight.
How will you equip the panel?
Well, the panel will have, I got on that wagon, on the back side of that wagon, you can see a battery monitor, which tells you how much power is left in the battery. It tells you what the voltage is, what the kilowatt usage is. That'll be mounted on the panel. So if you're flying it and you can see how much power you got left, how long you can keep going, it tells you what the usage is and everything. And it's seems to be a pretty good device. It's simple enough. And then there's a tachometer which is on there right now, which is just a little magnetic pickup, and that works fine.
Will you do airspeed, altitude, any of that sort of thing? Because Part 103 doesn't really require it, I guess.
Yeah, you know, there's probably no need for altitude, because you're never going to get high enough to make any difference.
Yeah.
As far as airspeed, I'll probably put one on there just for my own references, so I'll know what kind of speed the plane is flying. I have hooked up tubing and so forth in the wing, so I can put a pitot tube in. So I suspect we will have a airspeed on it. And of course the voltage and all that's in that monitor, so there won't be a whole lot on that panel, that's for sure, at least the way I see it right now. I might speak on the windshield a little bit. It's just a wrapped piece of Lexan. It's nothing special. It goes on, it looks really good, but it's not. It's a flat wrap, and we had to develop the shape of it. It took a little bit of doing to figure out just how to cut it so it would wrap nicely, but it goes on pretty easy. And it's got a carbon fiber fairing that goes around the bottom of it and holds it in place, and it slips in just like the Bearhawk windshields do. It slips in at the top of the fuselage. It ends up looking pretty much like a Bearhawk windshield, but it's just a flat wrap.
So you didn't have to form it any complex curves, just a single bend? Just
a single bend, and then a little bit of a fold over on the top, which is all natural. There's no heating required, just all done. It's Lexan, which, you know, you can bend around pretty good. It's 1/16 Lexan. And so it's not too heavy, of course.
It's not going to be affected by fuel at all, so there's no fuel on it.
Yeah, no,
Well, since you have a windscreen, what do you think this thing will cruise at?
well, I'm thinking probably around 70 or 80.
55 miles an hour.
But we're going to have to limit the RPM so we don't go over 55, is it? Whatever the spec
Not going
is.
faster than 55 miles
Yeah,
an hour.
Part 103 has a
As fast as it
straight and level limit, I think.
Yeah,
Not with the FAA.
no, we'll have to. We'll just limit the speed by the RPM. Put a red line on it. Yeah. It's like any airplane, though. If you want to go faster, all you got to do is put the nose down. There's no such thing as how fast will a plane go. Well, how steep do you want to dive it?
So will this have a Riblett airfoil?
It does. It has the same airfoil that as I use on the LSA. It's 6% camber, 13.5% thickness ratio.
Fabric covered?
Fabric covered. Everything's fabric covered. You know, the leading edge of the wing is carbon fiber, but I'm going to, I believe, run the fabric right around it just for structural reasons, just because it'll be easier than trying to terminate it. It's got a tail skid on it. Doesn't really have a tail wheel. I don't know. At this point, I don't see any need for a tail wheel. It's I've had a plane before. I had a Pete and Paul, and it didn't have a tail wheel, and I was fine with that. It had a skid. It's got brakes, though, so you can do. Pete and Paul didn't have brakes. This has brakes, so you can do differential braking to skid it around where you want it. And It's a fiberglass rod there, 3/4 inch, I think, diameter fiberglass rod for the tail spring, which is light.
How many airplanes will you have built with this one?
I think this is number 11. Yeah.
And then of those, I guess this is probably your 7th design or 8th?
Yeah, I'd have to add that up. Let's see, there was the Grasshopper, which was my first one, a single-seater. And then there was a aerobatic competition, aerobatic biplane that I designed, 260 horsepower, and flew for a while. The Grasshopper got flown a lot, the biplane not so much. And let's see, I built a Midget Mustang. That was the first plane that I ever built. Not my design though. And I built an RV3, flew that for 380 hours or something. I built a Pete and Paul, and then the first Bearhawk, which is in the hangar, still have. And then I built another version of the Bearhawk with the cargo door and the 260 horse on it. And then I built the Patrol, and then the LSA, and this one here. I think that's all of them. Sometimes I lose track, but
yeah. And then I guess there's the 5 you designed but haven't built one personally.
right, the Bearhawk 5, which I designed and kind of supervised a lot of the construction on it from a distance, mostly, although some of it was done here locally. That's up and flying real, and seems to be the guys that fly it like it, so it's doing good. Yep. That's the 6th place. The way it was built now, it's 3,000 pounds gross, and it's 1,500 pounds useful load, but it's coming along. We're building them down at the factory now.
So if you could pack this down small enough, you could load 5 of these, batteries included, into the 5. Is that why we call it the 5?
Yeah, right, right. Yeah, yeah. If you could squeeze it down a little bit. Yeah.
What size control cables are you running on this one?
Well, right now I got 1/16. I don't know. There may be some of it upgraded to 3/32, but right now everything's 1/16, and I'm kind of analyzing it for the strength of the controls and the strength of the parts that it's going to and so forth. And yeah, I don't know if we'll end up with all of them being 1/16, but right now they are.
I guess most of your designs have used the heat-treated aluminum. What did you use on the, because if you're welding on that, I guess, or is it just bonded?
Just bonded. This is all
okay.
bonded together. There's no welding. This 16 thousandths here on the ribs.
Wow.
2024. But the you know, the tubing is I think it's a lot of it's 6061 on the tubing. We use a little bit of 2024, but most of it's 6061 T6 on the tubing. And the 4130 socket joints, which is bonded and riveted, so forth.
Excuse me,
Tried
Mr.
several
Bob.
different bonding agents.
How did you come up with the idea of making an electric airplane?
I guess because there's a lot of talk nowadays about electric everything, cars, and some other people are doing some airplanes that are electric, and thought it might be interesting to try it.
An extra challenge.
Yeah. Yeah, it's been the electric part of it is a challenge, because you know, a gasoline engine, I understand it, everything about it, how it works, why it works, and how to tear it down, how to fix it. You get into this electronic stuff with what's going in on that controller, and there's a lot of, nobody seems to really know what's going on in there. Maybe the guy that drew it up did, but you talk to somebody else and they all got theories about how it works, but they can't tell you exactly what's happening, or exactly what to do to fix it. Somebody asks me about a gasoline engine, exactly what to do to fix it, I can pretty much tell them. But you know, I've had a lot of people looking at this stuff and what's in that controller, how it's programmed, what it's supposed to do, how it works. hook a computer up to it, it doesn't even tell you what's in it. But I don't know. It's a different world working with something you can't understand. But eventually it'll get worked out.
Any particular reason you went with a Q-tip prop?
No, Prince Propeller Company just had one extra. They just gave it to me to go ahead and use it for testing purposes. I think they're good propellers from what everybody tells me that has you flown them. They do real well, you know. They're very efficient, but then the electric motor will run either direction, just a matter how you put the wires to it. And that one's turning the wrong way for me, that propeller they sent me. But that doesn't matter for testing purposes. Eventually I'll put a prop on there that turns the correct way, because I've got the offset on my tail set up for standard rotation.
How do you come up with that particular electric motor? Where does that motor usually run, and why did you choose that one?
Well, a friend of mine out in California, Cedric Gentry, knew a guy in Ohio that it was a friend of his that had used that particular motor, controller, and battery pack on an ultralight he'd had flying a few years ago. And he had designed an airplane or something, and he was not going to do any more with electrical stuff. He was going back to gas. And so it was available, and I didn't really know if I wanted to buy it or not, but the price was good, and I said, well, I'll just buy this stuff and try to get more educated on electric systems, trying to find out how they work and why they work. And so I bought it as just thinking that I may not ever even fly that particular motor and controller, or even those batteries, but I would use it to get more familiar on electric systems. And it's certainly doing that. It's if it was just something you bought off the shelf, plugged it in, and turned on the switch, I probably wouldn't learn much. Maybe I'm going to learn something with this one.
Does that motor typically power an industrial tool, or is it?
No, it's made for aircraft.
Okay.
It's a Chinese motor. It's a Chinese controller, and
Made for drones, actually, that particular motor, for large drones.
maybe it's made for drones, yeah. But it was developed for use in airplanes of sort. But you know, I haven't found anybody in the U.S. that really was interested in working with me on this. There are some German stuff that's available, but they're only interested in working with you if you give them a lot of money. And it's a lot of money. You know, a year or two from now, and really learn a lot about this, and I get a couple people working with me that know what they're doing, we might just design our own motor and controller and say, to heck with the rest of you guys. We'll build our own. Or if we don't build it, we might just modify theirs to do what we want them to do.
Do you remember what your total wingspan is?
Yeah, it's 26 feet. 120 square feet of wing area. So it works out at around 5 pounds per square foot, fully loaded gross weight. That's with a heavy guy in it, 200 and some pounds. So it should land somewhere around 25, 26 miles an hour, I think. It's kind of nice. Take off about the same speed probably. If that motor develops 40 horsepower like it's supposed to, actually it's supposed to develop 40 kWs, kilowatts, but even if it develops 40 horsepower, it should be a good power to weight ratio for an airplane with that light of wing loading. I think that I'm concerned about the electrical part of it, whether it's really going to make any sense or not. But you could put a gas motor on it. It's just I don't know if I ever would, but certainly somebody else could. It'd be a great little airplane with a 70-pound motor on it or something, gas motor.
I guess this will end up being heavier than a combustion engine on the current technology, right? By the time you figure the total electric and the total gas, or have you figured that up?
Well, if you look at a two-cylinder VW motor, that weighs about 110 pounds. So, and then you got the exhaust system, and you got the, battery or whatever you use to start it with, unless you hand prop it. So I don't know. There's not a whole lot of difference because this motor weighs 23 pounds. The controller weighs about 4 pounds. So you got less than 30 pounds there, and the props weigh the same no matter which. And the batteries weigh 70 pounds. So you're still in the 100-pound range. It's not a whole lot different with a gasoline motor. Of course, there are some gasoline two-cycle motors that are lighter, but not everybody likes to fly behind two-cycle. Some people fly, if they got a parachute or something over their head, they fly with a two-cycle.
Do you think it would regenerate if you were to get up high and bring the throttle back or get into some lift on one of these ridges or something?
Well, I would think it could, but I don't know.
I guess it'd be up to the controller.
And I guess it's up to the controller. Yeah.
That'd be pretty neat. As many ridges as you have around here, you could take off and go get into some lift.
Well, yeah, that's my thought. We have a mountain right over here that's beautiful for ridge lift, because you usually get a west wind, and it's kind of a north-south ridge, and it has nice lift off it. I used to go over there with one of my planes years ago and just throttle way back and cruise along the ridge with the uplift off the ridge lift. So this should be really good at that, with a low wing loading like it's got. It'll be a fairly low drag airplane once it's covered and everything. It's a single strut wing, so it'll have a fairly low drag.
Wheel pants, maybe?
Yeah, I don't know. I doubt it, but
may not be fast enough to really pay for them.
Carbon fiber.
Yeah, there you go.
You could put them on, but the gear legs will be all, faired in, and probably a foam fairing or something on the back of the leg there, and all covered with fabric, so they'll be fairly clean. I can streamline the landing gear shock strut if I want to. And there's various things you can do to clean it up, but it'll be pretty clean anyways.
Do you have a figure of what the motor is going to draw at full throttle? Like how many amps or anything?
I guess it's close to 500 at full power. Mm-hmm. Yeah.
So you're not going to be able to run it at full power for very long. It's kind of a climb up and then get it on throttle and back.
Oh yeah, just climb up, probably climb 1,000 feet a minute. So just climb for a minute.
Wow.
It's a 120 volt system right now. 120, actually the monitors over there is reading 126 volts. But you can drop, as you run the battery down, it'll go down in voltage. I think Cedric, the guy that's working with me, said that probably we set the limits up on it, I think at 105 volts is where it would start flashing. It's time to go home or better land.
Because it's 700 something cells, is that right?
760 or 50 something. So, yeah, over 750. Yeah. I think that's in the last newsletter. There was some information on that.
Yeah, all the exact numbers.
Yeah.
What is the little hatch on top of the boot cowl where the clecos are?
Oh, that's really not a hatch. It's just a way of putting the top of the cowling on over those, just like get around those tubes.
Oh, okay. You had to split the boot cowl to be able to get around those. I got you.
Right. Yeah.
You don't have to check the oil.
No, there's really nothing much to check, I don't think, on it, as far as I know, other than making sure all the airplane controls and everything are working right, and check the battery voltage, and the monitor will tell you the percentage of charge left in it, and basically charges off a 110 charger. Of course, it'd take overnight probably to charge it, but it's I don't have a real good charger right now. I got 2 batteries there, and my charger is about 67 volts, so I charge one battery at a time, and I have to buy a better charger to charge both at the same time.
Mike, can you think of anything else to talk about?
Pretty well covered it. Mike, you're going to be using mechanical brakes on it, which are just band brakes, like a go-kart type thing. So Pretty simple there, lightweight. Will be toe brakes too, not hand brakes or anything like that. Of course, talked about the cowling be all carbon fiber. Made a nice beautiful cowling for it. So it'll look pretty stream. It looks just like a miniature Bearhawk. So should be a lot of fun.
It doesn't seem like a lot of airplanes in this weight and speed class are so streamlined. You know, it seems like you see a lot of external flying bracing and things like that.
That'll be a neat feature.
Yeah, it's a little different that way. Yeah, it's pretty clean.
This is going to be a bit more fragile than most of the other Bearhawk designs, just because of the lightness. So where the 200-pound gorilla meets the airplane, you're going to have to be a little bit more careful. You can't really rip the throttle. You're not going to be able to stand on the brakes really, really super hard. So, but you shouldn't have to.
Well, thanks a lot, Bob. I guess we'll stop the video and let you get back to visiting. This is October 17th at your annual picnic. It's been a good turnout.
Yeah, it's been a great turnout. Beautiful weather, and we've been watching a lot of nice flying going on here. Raleigh flew the patrol, and Raleigh's the one that did the original test flying on the Bearhawk 5. We've had a good time.
Yeah.